All right, let's jump right into this. Picture a completely automated, futuristic planet. No life, just endless glowing server farms and intricate, humming cities operating entirely on their own. Now, encircling this world is an invisible digital web, a high-orbit net of thousands of glowing satellites silently dictating the rhythm of the entire machine grid below. But imagine if, without a single warning, that entire orbital net just blinks out of existence. The sky goes completely silent. Welcome to our explainer on the massive, cascading, systemic collapse that hits when all orbital technology is just suddenly gone. It's a pretty wild scenario to think about, right? I mean, what actually happens when the sky goes silent? This terrestrial machine grid is held together by invisible, high-altitude tethers that are completely out of sight. So we're going to explore this immense hidden reliance on the infrastructure floating up there in the vacuum of space. And we'll map out exactly how this sterile digital world systematically unravels the second those signals vanish. Now, this collapse, it doesn't take years or even months. It's a rapid, escalating domino effect. Minute 1, orbital signals drop, and that immediate tether is severed. By hour 1, automated navigation is entirely blinded. Day 1 sees the global financial apparatus just freeze. And by the end of week 1, the global automated supply chains shatter into isolated, useless fragments. It is literally a precise mechanical timeline of catastrophe. So let's start with phase 1, the silent disappearance. 0 orbits, 0 signals. Just an absolute total blackout. Down on the surface, massive communication towers go completely dark. Rows upon rows of server farms sit in absolute silence, waiting for digital handshakes that are never going to arrive. The loss is so abrupt, so absolute, it basically severs the top layer of the planet's digital nervous system in a fraction of a second. There's no explosion, no warning alarms, just an immediate, heavy void where a highly complex technological ecosystem used to be. Moving right into phase 2, navigation networks go dark. You know, when we think of GPS, we usually just think of digital maps. But it's actually this massive orbital network providing continuous positioning and, honestly, more importantly, critical timing data to digital systems everywhere. GPS is essentially a giant, highly precise clock system floating in space. It acts as the unseen heartbeat for global automated logistics. Without those satellite signals constantly beaming down the exact microsecond, the machines simply don't know where they are or where they're supposed to be going. On land, the automated shipping networks grind to an immediate, screeching halt the second those routing algorithms fail. But out on the oceans and high up in the atmosphere, that is a terrifying kind of blindness. Autonomous aircraft and massive automated cargo ships lose their navigation mid-journey. They're just left drifting in a digital void without any coordinates to guide them back to automated ports. Which brings us to part 3, communication and data blackout. Long-distance data routing is the very first thing to fail when those orbital shortcuts disappear. Almost immediately after that, remote server connections are completely severed. Global telecom synchronization totally drops, which means routing algorithms can't coordinate complex data packets across the grid anymore. And finally, meteorological tracking goes completely dark. While terrestrial deep-sea cables do handle a massive chunk of data, orbital relays are absolutely crucial for load balancing. Think of them as the pressure valves for the entire global network, reaching those remote server banks that cables just can't efficiently connect to. When you remove those relays, the deep-sea cables are instantly overwhelmed by the bottleneck. This sudden, massive surge in traffic forces remote backups to fail. The entire data ecosystem basically buckles under its own fragmented weight. And the immediate disappearance of weather forecasting is especially severe. The radar goes completely dark, literally 0 meteorological data. Automated disaster response systems and environmental sensors are left completely blind to incoming storms, atmospheric shifts, massive pressure changes. The surface grid is just left to weather the environment all on its own, without a single early warning trigger. Let's look at the 4th stage, the financial system collapses. Okay, I really want to dive into this specific mechanism because it's absolutely fascinating. Atomic clock synchronization. Global banking servers rely on ultra-precise time signals beamed down from space to perfectly align automated transactions. It's crazy to think about, but it's this high-orbit technology that actually dictates the exact digital microsecond necessary for servers across the planet to talk to each other without corrupting the data. So when that time signal stops, the atomic clock synchronization fails. Automated server transactions halt instantly because of timestamp errors.
The machines literally cannot agree on what time it is, so they just reject the data to prevent algorithmic corruption. Within moments, global banking grids completely freeze up. It is a strictly mechanical, entirely inevitable failure of the whole automated economy.
Zero. Absolutely zero digital financial transactions can process once this timing synchronization is lost. The sterile, glowing data centers that process the planet's wealth just instantly become nothing more than dormant, incredibly heavy hardware. Next up, Section 5, Global Infrastructure Instability.
It is honestly staggering to realize the sheer percentage of terrestrial infrastructure that is entirely dependent on space tech. Automated power grids rely on orbital timing just to balance their electrical loads and prevent cascading node overloads. Automated logistics, as we saw earlier, are fundamentally reliant. Even highly isolated military defense networks require orbital components for secure, synchronized data transfers. The dependency is absolute. And this results in a sudden, incredibly eerie silence across global defense networks. Early warning systems go entirely offline. Radar installations and automated threat detection grids lose their secure communication relays. The defensive architecture of the planet becomes essentially deaf and blind, totally unable to scan the skies or share synchronized threat data between continents.
Finally, Section 6, a disconnected dark future.
The only path forward requires reverting to analog, and the process of attempting to rebuild ground-based communication networks from scratch is agonizingly slow. The systems would have to physically reroute massive copper and fiber cables, reestablish hardwired server handshakes, and completely bypass those dead orbital paths. It means entirely rebuilding the architecture of the digital world's hardware from the ground up, all without the benefit of those high-altitude shortcuts.
There's a quote that sums this up perfectly. The modern world is suspended by invisible, silent threads in the dark. It really forces us to reflect on the extreme, largely unseen dependence these highly advanced systems have on this fragile, high-orbit technological web. A terrestrial utopia of total automation was constructed, but it was anchored in the absolute zero of space. Which leaves us with this final, pretty profound question to consider. If the invisible infrastructure vanished tomorrow, how long would the digital world actually survive? It's a stark reminder of the sheer fragility of the automated systems that silently run the planet. Thank you so much for joining us for this explainer. Keep questioning the complex systems that surround you.